Hello. Today I'm going to add the type for macros. Macros are taking various arguments. We have regular arguments, we have references, and we did that last time. We have expressions, and here's the trailing body, but there's also the compile time variable, and we have the like type, right? So that's a type of some kind, and we'll work towards that. And so I should do something. I should throw that away, and we want to have a macro that takes this type here, and we could just use that type to get a something, right? And then we maybe return that one. So we could get a size from that. We could get a size of, when we take foo and we put in an int like that. So something like this should work. Size of int is this. So go through size of and getting that, and then we should have something else that's, we can have a size. So this should work eventually. That's where we're moving towards. And I like to just try and see where it breaks. So if you saw the last stream, that was what I was doing. So I'm just going to call this and see where does it break. And we had some here. We have something weird. Oh, the end. So boom, it says it expected a macro parameter here. Well, let's say why it think this is a macro parameter. We then go into the parser, and we do this on the global level. So it's the global parser, and if you remember last time we were here, we were parsing. We have some parse macro declaration, right? So we go, I think we wrote this last time. So go through, and we want to have all these different idents. So this is the, maybe we should comment this a bit. So this is the normal, like foo. And then we have maybe the compile time variable, and that's like a foo. And then we have a reference, and that's a foo, like that. And then we have the expression, which is the hash style. So it says like expression. That is a foo. Oh, and then thought it should indent like that. Shouldn't. And here we're just going to do the same thing, and it's actually the type ident is not allowed, right? So we can write that. Note that the hash type ident will be an error later on. We could like say that is, I mean, there's an argument for actually accepting this as well. And the reasoning here is, if I defer that to later on, then we can do more of the parsing, maybe. But since we do that, I mean, maybe we should say that this is not okay, right? Here. So we just make this a same error. So took expression can unevaluated can never be a type. Did you mean to use type? Something like that, maybe. Maybe that helps, you know. And then since this is, oh, here we have an error, because this should always return like a poison tickle. So this also returns a poison tickle. Okay, so now we're fine. This is like the this is not allowed, right? And now we get to this for the varargs. Now we get to the next one. So it's like this: compile time type, and that looks like CT, this one. So now the param kind is a vardicle. I already prepared for this, so that one is fine. And now actually this can't have a type. So if it does have a type, then that's an error actually. But let's ignore that for now and just treat that later on. Okay, so it will break now eventually. Like, we should note that we have this test case that we want to test, which is like maybe, you know, do something like this: int, you know, this is should not be allowed. Oh, right. So identify size of could not be found. Oh yeah, this is maybe should be like more like this, because I put that on types. So this is going to return a type. You can do the size of on should be able to do that on expressions, but let's do it like this. So ooh, we get an error. So it's somewhere over the rainbow we have this, and let me see if I can, you know, get rid of this one all the time. Always show them build. No thanks. Can I get that gone? So when we do the semantic analysis later on, we run into problems. And this is just like last time. And just say hello to everyone watching. And feel free to, if you have a question, post in the chat. I might not immediately answer because I'm concentrated on you know, writing the code, but I will try to answer. So I wrote a bit in the beginning. I just wrote some text, but one of the things when we work on the macros, especially, I think, is that, I mean, macros are not an essential part of a programming language. It's a nice to have, but not really super important. Which means that, and also have like there are really a lot of things that you can do with macros. You could really allow it to do, you know, the sky's the limit. So we have to be careful when we add features to the macros that we don't make them too complex. First of all, no one will want to really use them, or you could do like too weird stuff with it, like look at C++, what you can do with the templates and the macros. And it will, when you write the compiler, if someone else wants to write a compiler, then they will have like huge problems implementing the stuff. So I think in general, I want to keep the language super simple to implement. And this is like a bit different from, I think, how most people are writing their languages. They want to, you know, have an idea this is what I want to do. And I just want to improve a bit on C. I think C is fine. This is all C. I don't think it's hard to use. But there are missing ergonomics, obviously, that we can do today. And I think the problem with many languages made today is that they, like people are doing them, the ones that are done like hobby projects, complex. Go, because Go is not a super complex, and and uh, and Go was a great experience doing compilers. And I think Go is simple because they decided that like complexity in a programming language is also something bad. You know, it's good if it's fairly straightforward to implement. Anyway, let's get started. Before we went into this part, this code, which will do all the semantic analysis for a macro, the macro call, so like a macro invocation somewhere. Somewhere we have code like foo, blah blah blah, and that's what we're going to check here. So first we have to parse. We want to resolve everything here during compile time. So just this part of the code will be something that is actually executed. And if you look at something like Zig, Zig actually like puts everything in the language as sort of compilable, runnable parts. And then the stuff that isn't runnable, it will be like deferred to runtime. C3 is much simpler. It's just going to do it's going to do like constant folding and some magic in the macro calls, but otherwise it's straightforward. And something that maybe people don't realize is that C actually has a lot of constant folding built in. It has to have that because we have the if statement, and this one could have like something like 1 plus 1, right? Or if 1 plus 1 is bigger than 0, then something. So it must do some sort of constant folding. And people have exploited that actually to do a lot of weird stuff. But we don't need much more than that. And that's what C3 actually does. Okay, so anyway, we have the arguments, we have the function we have the function parameters, we have the arguments that are passed in. And now, right now, we're like, okay, if we mismatch, then we just say that that's an error, right? But we should be able to use var args. But we don't do that anymore. Or maybe we should have like default parameters. I'm going to support default parameters on functions because that's super convenient. I'm not sure that I want to do that for macros because macros are somewhat unclear anyway, so maybe you should like overuse macros. So that's the reason why I would like to maybe like limit what we can do. Anyway, so we go through these parameters, and we know now that we have the same number of parameters as the args. And what we could have gotten is like we get this foo. We saw that when we parsed, and we get this foo and that foo, right? And then we have this one. And now we get to our new one. So now we have to evaluate this one. So this one has to be evaluated during compile time to a type. But type isn't a valid thing as an expression, like the end of an expression. So we're just going to do the same, the type of analysis that actually produces what I call a value. That's not like the unresolved version of everything. So if you have a compile time variable, it won't actually completely resolve into the underlying type. So, okay, sorry, that shouldn't be a, if we have a type here, now we go into that. If this parameter actually has a type, then that's an error. Type. Oh, hang on. This shouldn't be handled here. This should be handled much further down the line. We will get back to that later. So here's a null because this is like the expected type, and we don't have that. We don't need to do anything. So, and then we have the arg, right? So you're going to do that, and if there's a problem, we already sent the error message, like output that. So now we want this to be a type. So if the arg, now if that isn't a type info expression, I think that's the type. Right, so if it isn't a type info, if it isn't a type expression, sorry, expression, and there's like some type info. If it isn't a type info, then it isn't a type. It could actually be a type of, I guess, like to do check type of. Right, if it isn't a type info, that is, it isn't a type, then we want to have something like a type was expected for the parameter double was expected for the parameter s. Yeah, and then we get to give a bit of hint, and we want to pass in the param and the name of that. So maybe get some hint there. Okay, and if now we're fine, right? So we're fine mostly, but we don't want to do this. We just want to say like resolve done. So in this case, the param, actually we want to do that. We want to, the param should not have a type, right? And then it has a type, which is that type. Yeah, I guess we can do that. We could just use the whole thing. So now it's time to test this. So now it's breaking when it's emitting the function declaration, which is a bit odd. So I have to figure out why it's actually thinking that this is a right. So just going to double check that. Right, so this is interesting. Compilers give you the most interesting weird stuff. So here it's, for some reason, it's decided that it want to emit. Oh, main is poison. So what happened here is that like somewhere we got an error due to this, but we didn't actually write an error message. So that can actually happen. So let me just see why it decided that this was a problem, right? oh, okay. So I did this one, I mean, this, I think I did this last time as well. Like, this is so stupid. Right, so now, so it's like, oh, it's not an error. I say this is broken. And now we're running it again. Okay. So this is not a type, apparently. Right. So the reason why it thinks that the type is not a type is that I probably don't unfold this thing correctly, which makes sense. I'm just going to see where that happens first. And I'm sorry, but this is like I have a lot of weird things here. So we got a decal, and the decal is a var, I guess. So this could never be a type, it says. But it can be. Actually, it can be. Right? We have the situation if. We could put that on top, right? So here. And we can do the fall through. I think I must like say that it has to be fall through. Yeah, because the GCC will, otherwise the GCC will complain later on because I have some errors on. So in this case, if like this this decal here is a var, right? It is like a var decal, right? But if the kind of var is a, you know, a decal something something something, decal var param cd type. So if it's one of those, or it is a var kind var decal local cd type, then we're fine. Then we want to actually, like, then it has to be a this thing inside here. It must be a type info, and it must have been resolved already. So it's going to be like a you can assert that it is. Just always assert on your assumptions. My assumption is that in this case, this init expression is a expression type info. And we saw that like elsewhere, it might not be. So because it's going to do the type of. But let's say that we assume it is, and then it's just going to blow when it isn't. Right, so we now know it's that. And we're assuming that also this is already resolved. So I'm just going to assume that as well. Maybe I can so yeah, I can probably assume that. So I also going to assume that this thing, the init expression, resolve status is also resolved done. No, it's done. Right. So that means we can basically return we can do the, instead of having that, we can like just simma. Oh, now I wanted to do something funny in here. Yeah, it's like it's going to resolve this type info identifier. Maybe it's actually better if I I'm just going to do something here and just to do, and then I'm just going to see where I end up doing that. So here's the fall through, sorry. So now we're doing this. So can I in some way close this? Like I want to hide this. So maybe like this. Okay. Oh, we're going deeper, right? We're going into the macro call. We have the statements. We want to do declare. We do a declare statement and want to, you know, what is the type info? And the type info happens to be a something. And so like the type info is a, maybe we should, you know, back here we see that type info is something like a, going down here, going down, and we see that the declaration is like this. Now what I want to do is basically I want to rewrite this type info somehow. So we're going to resolve this type identifier somehow. So I have to make sure that the data that I have here, how does it look like? I have a type info identifier. It is unresolved, yes. So I have just a name. So I can resolve that to anything. Actually, the type info is fine. I can just overwrite this. So I'm just going to overwrite the type info here. So the type info is going to get overwritten by the type info inside of this one, because this one is a type info, right? So it's a type info, type expression. This was a weird thing, type info, yeah, probably that one. So I'm going to overwrite those. I want to keep the span though. So, or maybe I don't. So I'm overwriting this one. And then, so now let's see if I need to do anything else. So now I have the correct type info. And then we're fine. Something like this, maybe. Does seem correct. Vaguely. Right, can't access size of an u long. Oh, that's weird. Yeah, you can't do it. Maybe we need to do something else. But it seems like we're getting somewhere here. Now we're just going to see maybe there's something like this isn't working. Index is usize. I don't like the usize name. I wish I had something better. So does this work? I guess, let me see here. That worked. So something's wrong here. So we get this one back. No, sorry. So this is actually not getting. This is just, I have to do it like this, right? So we have to do, let's do this instead. So we have the type, and then we're going to do like maybe size of, wait, hang on, we should be able to do this. Size of, maybe. We do this, like start out with this. Bum, bum. Identify size of could not be found. I thought I implemented that. So I guess we have to look at that and look if we have some size of. No. Do we have type of? We have type of. Then we should do like, okay, type of, and then do after the type of, I can do a size of. Okay, this is a very roundabout way to check that this works, but like I just want to make sure that the type's okay. Yeah. Okay. Right, there's the question. Is the fall through macro only for readability, or do you get a warning if you miss it? So it seems like GCC is having like different things happening on when you have W all, and one of those is to check the fall through. So that means that actually the fall through is going to have like a macro there. Let me just show that somewhere. So the fall through is, I guess this, but if it's like here, we get this. So get the fall through attribute. So going back to this, I guess it's not really working the way I wanted it to do. But we can still do something like, maybe we can do this. I'm just going to get that, and now we can like maybe have something like this. So we have a short and we have an int, and we assign this, or we can even do like this, and then we want to assign this. Does that work? Like giving us a, that compiles. Oops, here we got something completely different from what I expected. Hang on, we're there, yeah. Okay, so we want to go to resources, test fragments, and there we get everything, and I want to grab for, I was going to go to another window here and get what I wanted. So hang on. Because I'm super lazy. Oh, I guess I didn't have that. So it's like LD something, L system. And what's the, like what you have, then you have like the debug stuff. Oh, and then you have like this or something, maybe like that. Yeah, that should be fine. So it's because this is crossed to an int later on, so it's going to say what the smallest value is. So we're going to get, if you put this one, oh, it's not very exactly like max short. We're going to do a max byte as well. Let's do that. So we have like, yeah, okay, byte, something like that. Right. So now it's actually working. What I can do using this? Not much right now. But hey, it's yeah. You can, of course you can do this. Like this works. So now I can like have size byte, size short. This should work though. Yeah, and we could put something. We can make a struct. So we make our struct bar, and it has like maybe it has an int something, and we have another itself, and it has a short somewhere, and it's the same name, and we have a byte here. And now we're going to take like the size of bar, where is a bar. So there we are, and let's see if there are any questions. So, are there any questions at this point in time? I don't know how well this mic works. I'm like just doing super basic stuff, basic webcam and stuff. All right, we got that working. I'm just going to commit that. I like to commit things that are like, maybe I would rebase this so that everything works together. But so macro type arguments type, and this is not fixing everything. We have a few corner cases, like what happens if what's passed in here is something that I didn't handle, like what if it's a type of, for example. I won't do that now. I will do that later. I should have. Oh, we should do this though. We should do this. So this should be an error. This should not be allowed, and it's allowed. That's bad, right? Even if we don't invoke foo2, like with an int, maybe, like this should still not. I mean, this would probably, like raw type could not be used as an expression. Yeah, it like it's just going to be all sorts of weird. So this is not okay, and it should protest, and it should do so when it's looking through the macros. And here it's like parsing the macro declaration, right? So we have a macro, we do put that somewhere, and we do check that later on. So let's see, the macro parameter is somewhere parse, and then we analyze the macros here. Here it is. And then we should be super angry if someone would. Okay, hang on, this doesn't look right. Is this really called? Aha, no one is bothering to actually analyze the macro. Why not? Maybe it isn't even stored something. So when you get a macro here, it's a decal. Yeah, you parse it. Do you put it in here? Like, what happens in the, like if you have a function, does it do anything special? No, it just would just appear. But there should be something somewhere, making sure that the macros are okay. So let's see here. I get the so we have the analyzed decals, and this one is running from analyze struct members, so and so on. And this one is no, not the one. So there's several passes. So we put like the vars in here and with functions in here, but how are they populated really? So we have some register stuff, like we register functions. But what happens to macros? Where are our macros? They are not stored. Right, so that makes sense, because it was never stored, and then it's not there, and we don't even have an external name for it. Not that we need one, but anyway, like probably we don't need that. Macros, and then we'll break, and we have to have a list of those. So we just look at what the function does, and then we just going to do the same thing. So let's see, we don't code gen those, but we do want to go through them, and we do want to do stuff. So we want to like have a list of pass for them. So in the decals, we want to, before we do the after we do the types, maybe we want to just check the macros. Again, the macros aren't there yet, so we have to have like decal macros. And then let's see where those are actually. Oh, we don't need to do anything about that. So I think basically this should be it. Now we would start hitting things that I was assuming worked and were run, but it's not run. So because we get here, and now it's just going to boom, just explode, because these asserts don't hold. Right? We know it's a var, but it could be anything. So let's clean up this stuff. We have some time. So we can have like a var decal that is a param, right? If it's a param, then we want to, do this. That makes sense. We want to resolve the type. If it's it could be like a CT type, right? In that case, we like if it has a type, then that's a bad. Semi-error on that param, bad param. A compile time type parameter cannot have a type. So that would be wrong. Otherwise we're fine. And then we have like the var decal param expert, and those actually they are fine. We want to do the same thing to those. And in case we have like a param which is a CT, then that's fine. And we have var decal, let's see here, like the param ref, that's also fine to have, just resolve the type. So all of those are fine except this one, I think. And just in case, we add something later on, I prefer to simply grab these together. The alias should never happen. So all of these should be unreachable, right? And we don't have that. So Now it's going to check. And like we do very little checking here on the map. The parameter compile time type parameter cannot have a type itself, and it should point to the actual type, right? We should not. The problem is not the param; it's the type info. So it's like the type info there is the problem, right? So let's see if we can get that right. So that looks right, and now we can remove this. So and it still works. Good. Now we should run the test cases because maybe something broke doing this. So nothing broke. Right, sounds good. So now we're done. And yeah, I should just append that. Or did I actually? I didn't commit or let's see. So how does Git look? I did commit that. So I think it's always good to keep things clean. So let's just amend this stuff to that commit. So right. And this is actually all I have for today. I could, of course, continue with the macros. The reason I'm doing the macros, by the way, is that we want to use compile time stuff like the type when we finally go to generic modules. I won't do everything on macros because we can do quite a bit already, and we should do the for loops and I think the switch is almost almost done. Maybe it doesn't work for types yet, but that's something that could be fixed. But this is like still low priority for me. I want to make the big thing, which is those modules, those generic modules work, and they basically take either a you do like, okay, you have a module foo, and then it takes a few parameters, like a type, maybe like the common thing is like a type or another type. You have like a map or something, but theoretically you could also have like an expression, right? So you could sort of bake things given as sort of a comparison expression. But I'm not sure I want to do that. But I wanted to have that possibility, and I think we should be able to like have a like put in a constant. So you have like a foo, right? You have a foo that's a constant inside of this module. Now it will always be private, so you can like have an one. So you can like create something with argument 1. So a foo, a type, and I guess that's it. Like you want a foo parameter that's like a value. You want a value, or you want a type. And to do that correctly, the type should be working, and the global should be working, and you should be able to like, if the type is something, you should do something, and otherwise you should do something else when you generate the module. To have it done, I had to work more on the macros, like basically get them working, and I also wanted to check that Fibonacci was working. So we did the Fibonacci before. Wrote a simple Fibonacci macro, and it would resolve itself during compile time. So I think that next time I would like to talk about why I'm writing C3, but I need some, that would be more like a presentation, so that would not be compiler implementation thing. But I also need to write some stuff down, or I just going to go back and forth, just wandering out on a tangent. So thanks for watching, and see you next time, whenever that is. Like, I'll try to do something regularly, but on Thursday, perhaps on Thursday. Okay.